and how they could work with gases and measure gases. So it is used, or T, so little t, represents temperature in degrees Celsius. So on your memorization sheet, that was the difference between those two, where it was little t, should be, the unit should be degrees Celsius, and then the big T is in Kelvin, right? So big T is the temperature in Kelvin. Yeah, so it's really important that you use big T or little t when you're doing your calculations so that you keep your units right, okay? So, let's see here. So negative 273.15 degrees Celsius is equal to absolute zero, which we say is 0 Kelvin. So then, to go from degrees Celsius to Kelvin, green question, what do you think I should do, Addison? Yeah, a ratio would work too, but so it's like, so if 0 is, so 0 Kelvin means negative 273. Say I had 25 degrees Celsius, how do I find out how much Kelvin? You just minus it, okay? So you just, you just add 273.15 degrees, or yeah, to go from degrees Celsius to that Kelvin. So 0 degrees then is 273.15 Kelvin. 25 is 298.15 Kelvin. Now go to your memorization sheet for a minute. These should look very familiar. What was this temperature reading used for? SATP or STP? STP. But these conditions are difficult to work in, remember, because 0 degrees Celsius is a cold lab. So they use SATP, and this should be what you have for big T, right? For SATP. So that's where those come from. That's how you get the little t and the big T, the little t and the big T for those SATPs, okay? So then, negative 30 plus 273.15. Make sure you include the negative 30. So punch that into your calculator. What do you get? Or you could just think of it. 273 minus 30, right? There you go. Yep. And negative 273.15 degrees Celsius, that would be then 0 Kelvin. Okay, so just my biggest caution with this is be very careful about your units, because you don't want to use the wrong unit in your equation. So let's move on to the actual equation now. So this equation was developed by Charles. He noticed that there was a relationship between the temperature and, what do you think? What do you think he's going to observe? Relationship, what have we been talking about? Temperature and volume. You guys are on it. It's Friday, but you're still with it. You're with me. Yeah, I gotcha. Okay. As temperature increases, so does the what of gas molecules? Energy! Kinetic energy! Well, yes, volume. But when we talk about the specific molecules, the molecules don't expand, right? Like, yeah. So, but the energy of the molecules will increase, okay? As the molecules move faster, they exert pressure. See, you guys could write this textbook. You told me all of this before we even started the lesson. Right, Matthew, that's what you said. It bounces more on the container. So the volume, so they exert higher pressure. Isn't this fun? The volume of the gas will expand under this pressure until it reaches atmospheric pressure. So it's like if they can push the container of, they want to equalize out the pressure, so it expands it. So just like a balloon. Let's play with balloons. Okay? Does that sound fun? Where's my key? Found it. Okay. So I'll give you this. So okay, Charles' law states that the volume of a gas varies directly or proportionally, right? Proportional, right? Yeah. Okay. It varies directly with the temperature at a constant pressure and mass. Actually, no, I'm not going to use balloons. I feel like I'll confuse you because I'm changing this. Never mind. We won't. So our formula is V1 over T1 is equal to V2. Oh, you're still writing the thing, sorry. At constant pressure and mass. So we're not adding molecules of gas or taking away molecules of gas. And we keep the pressure the same. So this doesn't mean, there's no like 1 minus. It's just that the 1 is kind of there where the underline is. So it's just V1 over T1 equals V2 over T2. So that should go into formula memorization sheet. Okay? Under Charles' law. Charles' law. Where T1 and T2 are temperatures in Kelvin. Very important. So that's why, because our formula has big T, right? The big T. Don't use the little t. The big T, okay? Temperature in Kelvin. And your volume is probably in what? Guess. What unit? Very good. Oh, whoa. Okay, so let's do an example.